Hi guys, today I want to discuss the highly precise stone vessels made by ancient Egyptians from the Predynastic and Dynastic times. These vases, bowls, and dishes are some of the finest ever found during that era, which are made of a variety of stones, from soft alabaster to basalt and granite, showcasing an extraordinary feat of craftsmanship. Ben of the UnchartedX and Adam Young made interesting claims that ancient Egyptian stone vases are extremely precise, especially pre-dynastic ones, which show astonishingly tight tolerances, often measured in thousandths of an inch, microns, revealing or exceeding modern precision engineering. Ben stated that the precision in materials like granite suggests advanced, possibly mathematically driven machine manufacturing, challenging traditional views of ancient tools and methods. It's also conjectured that a stoneware such as this has not been found from any later era in Egyptian history since the required scales were lost. The precision statement leads to an ongoing debate between mainstream archaeology and alternative theories, lost ancient high-tech. On the other hand, in 2025, physicist Dr. Fomitchev-Zamilov published a paper on Nature Heritage Sciences presenting 3D scans of 68 stone vessels of three groups, 19 from Predynastic museum pieces, 25 modern machine-made, and 24 contemporary handcrafted vases. With a quality metric based on concentricity and circularity, he concluded that these archaeological artifacts are 100% the work of human craftsmanship with ordinary tools. He pointed out that the so-called ultra-precise vessels are only found in private collections, but not authenticated museum pieces, thus likely modern forgeries. So, were these Egyptian stone vessels the work of lost ancient high-tech or manual labor? Even if some of the stone vases were machine forgeries, there are still many authentic and precise ancient stone vessels that appear inconceivable to have been achieved by using primitive stone chipping technology. Or are we underestimating our ancestors once again? Many reports and arguments solely focus on ancient Egyptian stone vessels without putting them into historical technological context, which might have skewed our judgment. In this video, I'll place these stone vases to their historical landscape along with the available contemporaneous tools ancient people possessed. I'll talk about the physical evidence found on the Egyptian stone vessels that illuminate their creation methods, and discuss if the relatively primitive tools were adequate to produce precise stone vessels. To avoid possible modern forgeries, I only cited information and photos from museums and published scientific reports, which links are in the description section. I'll also explain how these stone vessel creations might share some fundamentals with modern stone turning and machining, which shows millennia-long continuation of technological development. Did you know that fine stone vessel production had a long history and was quite common in the much earlier Neolithic times? In Egypt, stone vessels appeared as early as the pre-dynastic culture Naqada period, 4000 to 3100 BC. Naqada is in Upper Egypt, a Chalcolithic or Copper Age culture. Starting from 3500 BC, in later Naqada phases, precise stone vessels became significantly more common and sophisticated, but they were actually late bloomers in history. 11 to 12,000 years ago, at Göbekli Tepe, Karahan Tepe, and Kortuk Tepe, humans created nice stone pots, plates, bowls, and troughs of various sizes. These stone vessels predate the earliest Egyptian ones by 5 to 6,000 years. Kortuk Tepe is the oldest known Neolithic archaeological site in Turkey, occupied from 10,700 BC throughout much of the Younger Dryas, for a period of more than a millennium. The stone vessels from these Levant sites have beautiful round shapes, thin edges, smooth finishing, and delicate geometric and animal carvings. Some have small holes drilled on the sides. These artifacts are made of limestone, chlorite, and harder greenstone. The tools found at Karahan Tepe, which likely relate to the production of these stone vessels, include stone assemblage made of flint and obsidian, chisels and adzes made of river pebble, flywheels, grindstone, and pestles. At Quartic Tepe, several percolated stone pieces were excavated along with stone bowls. Judging from the stone sizes and the placements of the holes, these are probably flywheels and handhold for pump drills. Pump drill use a flywheel, often a weighted stone or pebble, to add weight to maintain momentum, allowing the user to push a crossbar up and down to create rapid, oscillating rotation for making fire or drilling holes. Ancient drills harnessed human power to generate rotational energy, which was then applied to a work surface, often with an abrasive material, to bore holes. These technologies, some dating back over 12,000 years, utilized simple mechanical principles to achieve astonishing results. Despite their immense antiquity, pump drills and their cousin bow drills maintained their currency in the maker's toolkit well into the Industrial Revolution and in some places into the 20th century. These archaeological finds in Levant indicate that the pre-pottery Neolithic people were capable of making regular-shaped stone vessels and large round plates with primitive tools, 5,000 years before the birth of the earliest Predynastic Egyptian stone vases. A puzzling thing about the ancient Egyptian stone vessels is that some of them are in really hard rock, such as granite. Granite typically rates between 6 and 7 on the Mohs hardness scale. Granted, these stone vessels mostly are in soft calcareous rocks, especially travertine or Egyptian alabaster. Indeed, many are in harder stones like granite or diorite, albeit generally smaller and less numerous. For softer rocks at Mohs scale 3 or lower, grinding and percussive tools of chisels and points can be effective for shaping both the insides and the outsides of the vessels. But how did ancients create these excellently smooth and rounded vessels in granite, basalt, and other hard stones? Egyptian stone vases' surfaces are often carefully smoothed out and polished, whereby original tool marks on the exterior were erased. Fortunately, there are visible production marks on some finished and unfinished vessels. This is a basalt jar from the Qaeda 1st to 2nd period in the British Museum with a description that there are striations made by stone drill bits inside the jar. Historians documented that the interior of many stone vessels show clear rotary drill marks or lathe marks since at least Naqada 2nd phase, 3500 to 3200 BC. But what can be observed on these pre-dynastic basalt jars with lug handles? Here is an unfinished Old Kingdom basalt vessel with circular rotary abrasion marks on the outside, which had not been polished off. Quite a few researchers believe that a certain type of lathe was used. Could pre-dynastic Egyptians have such rotational devices? As mentioned before, pump drills and bow drills are rotational tools. They were basic yet ingenious, widely used in many parts of the ancient world, including pre-dynastic Egypt, for fire starting, woodwork, stonework, and bead making. Bow drill uses a bow and string wrapped around a spindle to convert a back-and-forth motion into a continuous rotational motion. This allowed for greater speed and sustained rotation. The spindle drills into the fireboard, creating enough heat to start a small friction fire. These drills were a significant advancement. By using a hard drill bit like flint fitted to the spindle, and often utilizing an abrasive agent like sand and water, a bow drill can drill holes in rock through the principle of abrasion. Here are some disc-shaped stone mace heads with pretty precise drilled holes dating to 4500 to 4000 BC, before the dynastic Naqada culture. The conical-shaped holes signal stone drill bit work. Then we have these Naqada-era stone mace heads, one made of diorite, with drilled holes showing concentric lines which are unmistakable signs of drilling. These drill marks are very similar to the striations inside stone vessels. You may notice that the shaping and construction of these stone mace heads was not that different from stone vessels, as both involve shaping stone to a symmetrical smooth form and drilling a hole in the center. Plus, the sizes of these stone mace heads are comparable to many smaller Egyptian stone vessels, like the ones made in granite. Granite is no doubt very hard, but pre-dynastic Egyptians used to drill even harder materials, gemstones. Around 4000 BC or earlier, Egyptians used lapis lazuli, carnelian, and garnet in jewelry design. Here is a string of beads dated to 3300 to 3100 BC, made of carnelian, garnet, quartz, and glazed steatite. Quartz is a very hard, durable mineral, ranking 7 on the Mohs scale, harder than granite. Carnelian is a form of quartz with a hardness ranging from 6.5 to 7, equivalent to hard igneous rocks, granite, and diorite. This is a 3300 BC pre-dynastic diadem, a jeweled headband composed of turquoise, garnet, gold, and malachite. Garnet rates 6.5 to 7.5 on the Mohs scale. A red luminous garnet here surpasses quartz in hardness. This hard gemstone appeared in pre-dynastic Egypt and the A-group cultures of Nubia, and continued to be used until the end of the New Kingdom. Red garnet beads were typically small and often drilled from both ends. The ability to work such hard stones indicates sophisticated craftsmanship for the period. Beads made of lapis lazuli were found in excavations at the Naqada sites, dated to 3650 to 3100 BC. Lapis lazuli was a favorite gemstone in ancient Egypt and imported as raw luxury materials from Central Asia. Lapis lazuli's hardness is usually 5 to 6 on the Mohs scale, which is the same as basalt. If pre-dynastic Egyptians can make intricate beads out of harder minerals, carnelian, quartz, and red garnet, then it's not that surprising they were able to create nice basalt and granite vessels. They might have also used quartz as drill bits. Pre-dynastic Naqada culture from over 5,000 years ago was by no means primitive. Besides the jewelry, stone maces, and vessels, these people created other impressive objects as well, such as these stunning cosmetic palettes made of siltstone. Originally, these palettes were to grind and apply ingredients for facial and body makeup. The decorative palettes of the late 4th millennium BC appear to have lost this function and became commemorative, ornamental, or possibly ceremonial. Naqada people were also masters of stone knapping and ivory carving. They made this flint dagger with an ivory handle that was exquisitely carved with war and hunting scenes. To work on remarkably hard gemstones, ancient Egyptian laboratories used natural materials like flint, bone, bow drills, pump drills, stone and copper chisels, and sand and emery mixed with water or oil as abrasives. Abrasives are of paramount importance in ancient lapidary that enabled craftsmen to cut, shape, and polish materials harder than their metal or stone tools. Without abrasives, ancient artisans could not have worked with hard stones, since metal tools like copper or bronze drills alone were ineffective on minerals like carnelian and garnet without the addition of a harder grit. Certain skills and tools of lapidary and stoneworking are transferable. From these percolated stone objects and gemstone beads, we can tell abrasives and human-powered rotary drills were utilized in pre-dynastic Egypt at least 6,000 years ago. However, archaeological evidence of bow drills only appears 2,500 years after in the New Kingdom. Because most of the drill parts, wood shafts, bows, leather, and strings are perishable and inconspicuous. Flywheels and stone sockets, aka handholds for abrasion, are frequently ignored or misidentified. Stone and copper drill bits can be small and hard to distinguish. Therefore, drills are nearly invisible in many assemblages. So far, the earliest known depictions of bow drills are from a New Kingdom tomb of Rackmeyer, dating to 1479 to 1400 BC. Its well-preserved wall reliefs demonstrate several drilling operations, from bow drills for carpenter work to a different bow drill for drilling holes in beads, to another weighted drill with a curved handle which specialized in drilling the interior of a stone vessel. Now, this special stone drill in fact has much earlier portrayals, over 1,000 years earlier, in Old Kingdom art. Here is a relief of a stone vessel production from a 5th dynasty tomb in the late 26th to 25th century BC. Two workers were holding the angled or curved top handles of hand drills weighted with bags of stones to create a rotary motion to drill and hollow two stone vessels. Two people polishing the outside of the vessels with stone, and one polishing the inside of a big jar. There is a small explanatory drawing above the stone drill, showing the hidden bottom component of the drill, which is a horizontal drill bit mounted on a forked shaft. The drill was a vertical, weighted, and counterbalanced boring bar. Based on needs, artisans can switch between smaller or bigger drill bits to drill the narrow neck or the wider body. Drill bits were made in various shapes and of many materials in flint, diorite, quartzite, limestone, and copper tubes. In 1983, two doctors performed experiments using a bow drill with a copper tube to operate on red granite, either with or without the assistance of abrasives. They found that abrasives in a watery slurry or a lubricant such as olive oil can produce concentric cutting lines. Here is footage of a recent experiment done by Scientists Against Myths YouTube channel using a weighted drill with a copper tube like the ancient Egyptian one to drill granite, along with abrasives. When one rotates the handle, the weight of the stone builds up a rotational kinetic energy and helps maintain smooth, continuous momentum for boring the hole. The stone weight of the drill provides constant downward pressure on the drill bit, which replaces the need for the artisan to physically push down, thus requiring less effort. The added mass and inertia of the weights reduce momentary inconsistencies and speed fluctuations, ensuring a smoother and steadier rotation of the drill bit, much like a flywheel in a pump drill. The copper tube acts as a carrier for harder mineral grains inside the abrasive slurries, which do the actual microscopic cutting or grinding. This tool drilled through red granite and generated a core with tight concentric lines, resembling the marks on granite cores found at ancient Egyptian sites. These experiments proved that hand drills can drill through hard granite and create circular lathe-looking markings observed on Predynastic and Dynastic stone vases. Drills on hard rock often leave fine, more pronounced, concentric abrasion rings and a rougher finish. Softer stones, e.g. alabaster and limestone, yield much easily to the abrasive, which means tooling can achieve a smooth finish relatively quickly. Stone drills must have been important tools in ancient Egypt, because a hieroglyph was created to describe stone drills and craftsmen from the earliest dynasties, and the hieroglyph looks just like a stone drill. There are around 700 hieroglyph characters in the Old Kingdom. Stone drills were consequential enough to gain a place among the 700 hieroglyphs. It's very possible that the 5th dynasty murals of stone drills also came much later than the use of such tools, like the bow drill depictions are thousands of years behind. Perhaps pre-dynastic people used weighted drills too to make stone vessels. From these wall reliefs, we learned that the exterior shape of the stone vase was carved first, while the drilling and hollowing out the interior came after. The drilling was accomplished through rotational motions created by hand drills. But till today, there is no surviving illustration on how the highly symmetrical exterior shape was achieved. Judging from this Old Kingdom basalt bowl with rotary abrasion marks, probably ancient Egyptians had some kind of lathe or turning tool where stones were being rotated to speed up the shaping and smoothing process. That would explain why their vessels are so exceptional with tight tolerances and low circularity deviations. Some of you might have seen videos of Olga Vidovila using primitive tools making of rock, wood, rope, emery, sand and water to make vessels of breccia and diorite. The cutting, shaping, and polishing of the stone were mostly done by another piece of rock and ropes with abrasive slurries. The drilling, hauling out of the interior of the diorite vase was created by wooden drills with abrasives, which is more primitive than dynastic stone bits and copper tubular drills. When compared with a similar museum piece, the diorite replica vessel presents equal or tighter tolerances than the Egyptian one. This is in line with Max Fomitchev-Zamilov's 3D scanning discovery that the precision levels of modern handcrafted stone vessels are on par with pre-dynastic artifacts. These experiments give enticing insights on how basic percussive and rotary tools and abrasives can achieve great results despite taking a long time. Since pre-dynastic Egyptians were proficient with rotary drill tools, it would have been natural for them to have created or adapted other rotational crafting methods, i.e. a potter's wheel. There is evidence that pre-dynastic Egyptians used turning devices for pottery making. Instead of holding and shaping a small stone vase by hand, or rotating and chiseling a bigger stone vessel placed on the ground, a rough-shaped stone can be secured on a single-axis lathe, a potter's wheel, or an Egyptian stone drill. When the lathe or drill was turned and rotating, a worker can place a piece of hard stone or a tool with a flint tip and add abrasive slurries to abrade the rotating stone, which would gradually grind and shape the stone to an ideal form. This is pretty much the same as how modern stoneworkers use motorized lathes and stone chisels or carbide-tipped tools to carve stone vessels. Although modern artisans have superior rotational machines and harder abrading bits, thus not needing to add abrasives, the fundamentals of stone turning has remained unchanged for millennia. It's interesting to see that Stone Age bow drills and pump drills, dynastic stone drills, ancient potter's wheels, and modern lathe machines share foundational physics principles regarding rotational motion. By the way, the claim that ancient Egyptians lost their stone vessel production techniques, hence they stopped making stone vases in later times like the Middle Kingdom, is false. There are plenty of artifacts to prove that the precise stone vessels had been made throughout ancient Egyptian periods all the way to Roman Egypt. Stone vessels were luxury items that only the elite have access to. As such, they were frequently imitated with less expensive materials. Different eras had different tastes and preferences. Thereby, the stone vessels varied in style and uses. Over years and various eras, Egyptian stone vessels served as status symbols, used for funerary, display, and ritual purposes, cosmetic containers, and as canopic jars. Ancient Egyptians did not lose their skills in making highly precise stone vessels, though the popularity and production of such vessels might have diminished as the emergence and trend towards more elaborate metal vessels arose. On another note, during the Bronze Age, the superb Egyptian stone vessels were prized and collected by other cultures at East Mediterranean and possibly inspired other civilizations. The Cyclades and Minoans are examples to make stone vessels according to their aesthetics. Okay, to recap, prehistoric cultures accomplished amazing stonework with basic yet ingenious tools. 10 to 12,000 years ago, Neolithic humans in Levant had stone tools and pump drills and created circular, smooth, and sophisticated stone plates and bows. 4 to 5,000 years later, people who lived in North Africa used pump drills, bow drills, and abrasives to make percolated disc-shaped stone mace heads. Several hundred years after, pre-dynastic Egyptians of the Naqada culture with similar and improved tools and methods crafted gemstone beaded jewelry, finer mace heads, and symmetrical stone vessels. About 500 years later in the Old Kingdom, large numbers of stone vessels were manufactured via weighted drills, abrasives, stone bits, copper tubes, and other possible rotational devices. Multiple groups of researchers have done experiments utilizing time-correct tools to recreate stone vessels and drilled cores. and the end products very much resemble the ancient Egyptian ones. The development of stoneworking technologies has been continuous and gradually advancing over time. The reason why stone vessels were not made as much in later periods is because metal objects became prominent and overtook the role of the status symbol, whereby making time-consuming stone vessels stopped being profitable and less in demand. As a result, I think the precise Egyptian stone vases were made by traditional tools, not lost ancient high-tech. There remains the possibility of lost advanced civilizations with the machinery. Just the Egyptian stone vases were not it. What do you think? If you have any insights, please leave a comment. If you like my video, please subscribe to our channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.